So, hello, I'm Axel Richard, consultant at OBO, and today I will show you how to build graphical web applications through the example of SysON. At the end of this talk, you should have a better understanding of what is SysON and how it's made thanks to Sirius Web. We will also focus on the extension and customization capabilities of Sirius Web and how we'll leverage them in SysON. Okay, so the first part will be a presentation of Sirius Web, SysON, and the SysML v2 standard. Then I will make a demo of SysON. After that, we will see how we have used the Sirius Web capabilities, especially its API builder, and some example of extensibility and customization. And finally, a quick word about the test in SysON. First of all, a quick reminder about Sirius Web. It's all the power of the Sirius desktop approach, but this time in the cloud. It's an open source, low-code platform to define custom web applications supporting your specific visual languages. And it's hosted by the Eclipse Foundation. So what's inside Sirius Web? The Sirius Web project is a ready-to-use modeling framework to define and render graphical applications in the web. You could embed this framework in other applications as you like. It also provides an open source model server with various components that you can reuse. With this, you can build your own Sirius Web backend for your need. And on top of that, it provides a complete open source application offering tons of features such as diagrams, properties, forms. This allows us to integrate Sirius Web components to modern cloud IDEs. And finally, Sirius Web relies on regular web technologies like Spring Boot, GraphQL, React, and Material UI, to name a couple of them, along with others like XYFlow or EMF. In addition to the Sirius Web open source project, we provide the OBO Cloud Platform, which comes with additional features compared to Sirius Web, such as authentications, role-based access, or history of versions. OBO Cloud Platform is developed as an open core product based on Sirius Web. It provides enterprise-grade features and can be deployed on public and private clouds or on-premise environments with support and upgrade guarantees included. Then, what is SysON? SysON project provides an open source and interoperable tool for editing SysML v2 models. SysON showcases graphical editors using the capabilities of the Sirius Web modeling platform. And SysML v2 is a general-purpose modeling language for modeling systems that is intended to facilitate model-based system engineering, or MBSE. So an MBSE approach to systems engineers. The specification of the language defines both a textual and graphical notation. You have an example here on the screen with a model represented by textual notation on the left and its equivalent as graphical notation on the right. SysML v2 is standardized at the Object Management Group, the OMG. If you want more details about it, you can find the SysML v2 specification on the OMG website. So now let's go for a demo of SysON. So here I'm on the home page of my SysON instance. I can see all my existing created project. Here I have only one. And then I can create a blank new empty project if I want, or I can use one of the two existing templates. The first one is the SysML v2 template, allowing you to create a project, but also a document containing a SysML package model element and a general view diagram created on this package element. From there, the diagram is already opened, And from there, you can start modeling your system. So I can create, let's say, a package, then inside the part definition, and inside I can create, let's say, an attribute. Okay, so you can see the SysML v2 template as a booster. And we also have the Batmobile template, which is an example project. So let's create the Batmobile project. So here you also have the project that has been created along with the Batmobile example. Here you can see that there are dozens of elements, of semantic elements. Okay, so we also have a general view diagram already created and open. So I can use the add existing element tool, which will add all the existing elements of my model in my diagram. So okay, so now let's use the layout diagram tool, and here I am. All my semantic R elements are graphically represented in my diagram. Okay, so here you can see the general view, but we also have other kind of diagrams. We have action flow view, it's dedicating for action and flows between action. We have state transition view for state and transitions between state. And we also have interconnection view. For example, on part element, you can create interconnection view diagram. So all this diagram comes from the SysML v2 standard. On the left side of the screen, you can see the Explorer view, which contains all the documents present in my project. So from this, I can also create element if I want. I can create it from my diagrams, but I also can create element from the Explorer view. So here I can create, let's say, a new calculation definition element. I can also, from this Explorer view, hide some elements with the filter. So here we have 4 filters we have implemented in SysON. We will talk about that later. I can also, if I want, create some objects from textual notation. In the previous slide, I said that the SysML v2 standard comes with textual notation and graphical notation. So here I can add an attribute by typing SysML v2 textual notation. So let's say my attribute, okay, and okay, I can create object. Okay, and here we are. I have here my attribute that I've created from textual notation. I can drag and drop elements from the Explorer view to the diagram view. Okay, and here we are. I have my attribute represented as a graphical element on my diagram. On the right side of the screen, you can also see the details view, which allows you to view and set all the properties of a selected element in SysON. So either you select an element coming from the Explorer view or coming from the general view or any diagram opened in your environment, then you can edit all its properties through the details view. We have 2 tabs. The core tabs contains the main properties, the most important properties of the selected element, and the advanced tab contains all other properties. I can also import textual SysML files. So let's say here I have a small textual SysML file named OCX.sysml, which contains only a package named vehicle model, a part definition, and an attribute. Okay, so now let's import this file into SysON. So I just select the file, I upload it, and Once the upload is finished, then, okay, my document has been successfully uploaded in SysON. Now you can see that I have a second document in my Explorer view named OCX.sysML, and you can see that I have all my elements that were in my textual file. I can create, if I want, a new diagram on this new model, okay? I can drag and drop element. I can see the content of this element, and you can see, okay, I have my engine and my mass attribute. I can also direct edit my elements from my diagram. Let's say engine renamed here, okay? And now I want to export my document as a textual file. So I can just click on my document and click on download. Okay, and here we are. I have a new SysML file with the model exported as a textual file. You can see here engine renamed. Okay, so let's go back to the presentation. So now, let's dive into the code base of SysON. On the backend side, the code is organized as modules. First, you have the SysON application on the left of the screen, which aggregates all modules. It's a Spring Boot application. Then, we have the SysON application configuration module, which contains all the customization and extensions from Sirius Web we've done in SysON. You will find here the Explorer view filters, the custom view, the custom details view, the standard libraries, and many others. This module depends on SysON services module, which contains a lot of code pieces shared by all modules. It also depends on the SysON SysML metamodel module, which, as its name suggests, contains the metamodel of the SysML v2 modeling language. Then you have the modules allowing to import textual SysML into SysON and export models from SysON into textual SysML. Then we have the diagrams. Each description of diagram, the general view, the action flow view, the state transition view, and the interconnection view is contained in a separate module. All diagrams modules depend on the SysON diagram command view module, which contains all the common behavior shared by the diagrams. This modules-based approach allows to easily reuse the SysON modules in other Sirius Web-based applications. For example, let's say you want to create your own application with only the import module, but not the export module. You want the SysON diagram action flow view module, but not the other diagrams. And you want to keep the same customization than SysON. Well, it's possible and pretty easy. You just have to depend on these modules in your app and just ignore the others. On the front-end side, we have two modules. The SysON components module contains the most part of the front-end customization and extensibility. It's the twin of the SysON application configuration module we've seen just before, but for the front-end side. The SysON module contains some customization, like the icon and the home-page footer. It also declares the Sirius Web application component, which is the entry point of a Sirius Web-based application. About the build, the front end is built first, and the resulted artifacts are copied into the front end, the SysON front end module in the backend. Then the backend is built and produces a single fat jar. Okay, now let's talk about the Sirius Web API builder. Sirius Web diagrams are conformed to diagram descriptions. A diagram description is a kind of representation description. Other kind of description exist in Sirius Web, such as forms, Gantt, or trees. Each representation description can be described with a low-code approach directly through the Sirius Web interface. You can also, if you prefer, describe your diagram description in Java. And that's what we do in SysON, in each backend module related to diagrams, as we've seen earlier. The API builder facilitates the writing of such descriptions in Java. Here is an example of the API builder. Here, we create the general view diagram description. For that, we use the diagram builders class coming from Sirius Web. It allows to easily set all attributes of a diagram description. Like if we want an automatic layout, here we said, oh, we don't want an automatic layout, we set it to false. Or on which type of elements the diagrams could be created. Okay, on our case, it's the domain type. The domain type, we say, okay, we want to create the general view on namespace element. Namespace is a very abstract kind of element in the SysML v2 standard, and it's the it's a super type. Most concept in the SysML v2 standard inherits from the namespace. So basically, it means that the general view diagram will be able to be created on almost all elements, SysML v2 elements. You can also set the title expression to give a default name on each instance of a general view that will be created. Inside a diagram description, you also you must describe which nodes you want to manipulate, which graphical nodes. So another example here is a node description, the package node description. It's the node description used to define how packages will be graphically represented in diagrams. Here you can see that we set a default height, a default width, that the node represent is associated to SysML v2 packages. So the domain type here is on packages. You can also see, for example, that this kind of node will be resizable on both directions. But the API builder is much more than that. You use it also to define the graphical style of your nodes, but also the behavior to describe the behavior of your nodes. With Sirius Web, you can also create other kind of description, such as form description. The Sirius Web API builder allows to create all kinds of descriptions. Here is an example of a form description with, on the left side of the screen, the first part where we define a widget description, a radio button widget. We describe that what will happen when you click on the radio button, here on the edit radio variable. Then we describe the radio button itself with the radio description variable. Here you can see that the behavior of the radio button has been put in the body method. Then on the right side of the screen, we define a group description, which is just a widget container with a name. Here, our group description contains only one widget, our radio button. Then a page description, which will be represented as a tab inside the form. If you remember, on the details view we've seen before, we have two tabs, core and advanced tab. So here we only have one tab for our group description. And finally, the form description itself is created. Now, let's talk about the extensibility capabilities of Sirius Web. On the backend side, an example of extensibility is the Explorer View filters. In SysON, we have 4 filters allowing to hide some technical elements or hide the standard libraries. It's quite easy to provide a new filter. All you have to do is to implement an iExplorer 3-item altered content provider from Sirius Web and provide it as a Spring service. You can see the art service annotation before the class declaration. The canHandle method allows to say when the filter has to be applied. And the apply method allows you to alter the content of the Explorer view. Here, we hide the root namespace element, which is a mandatory but very technical element that is useless for most users in SysON. Another extensible capability of Sirius Web is about the diagram panel. Each diagram displays a panel of actions, such as full screen mode, export diagram as SVG action, and many more. These are the default actions, but you can also provide your own actions. Let's see how we did it for the show icons action. So here you can see that the show icons allows to hide or show the icons in the diagram. The SysML v2 specification doesn't use icons on graphical notation. So to comply with the specification, we provided this action and let users have icons or not. On the front-end side, we have a small React component with a checkbox from Material UI. Then we have a GraphQL query called when the component is mounted or refreshed. This query asks to the backend, what is the state of the action, checked or unchecked? Then we have a GraphQL mutation called when the user clicks on the action. It sends to the backend the new state of the action. On the backend side, we have several parts. The first part here is a data fetcher. Its role is to answer to the query we've seen in the previous slide. Then we have another data fetcher, but this time to answer to the GraphQL mutation. Its role is to send an event that will be queued and handled by Sirius Web. Here we send an event with a show diagrams icons input here, an object containing all the relevant data for achieving the mutation. Finally, we need to implement a diagram event handler as a Spring service. The canHandle method allows to know when this event handler should be called. The handle method does the actual mutation. Here, it sets the show icons value, then it sends back a payload to the front end, indicating that everything is okay, and that a specific diagram change will happen, a diagram element visibility change. Sirius Web will then know the diagram will have to be refreshed to take into account the change. Other examples are the tools palette. While the standard way to add palette tools is to define them alongside node description or diagram descriptions, you can also declare some tools on the front-end side with the appropriate extension point. The menus in the Explorer view are extensible. Here we declare the new object from text menu item with the extension capabilities of Sirius Web. A last example is on diagrams. You can provide some React components that would be rendered in addition to the diagram described on the backend side. Here, the screenshot shows two permanent cards, a legend on the bottom left corner and the Learn More card on the bottom right corner. There are a lot of other extension capabilities in Sirius Web on backend and front-end sides. The latest are described in the OBO blog, as well as every significant new features and improvements of each release of Sirius Web. So do not hesitate to visit the OBO blog if you want to stay tuned with the latest versions of our products. Okay, so now let's talk about customization with Sirius Web. Contrary to extensibility, customization is more like changing an existing behavior or changing an existing capability offered by Sirius Web. For example, on the backend side, the details view can be customized, and that's what we did in SysON. All we have to do was to implement our own iProperties description registry configurer and provide it as a Spring configuration. Then we declare the form description with the API builder we've seen previously. That's what we've done in the Create Details view. This form description is then added to the iProperties description registry used as a parameter of the add properties description method. What we don't see here is that the form description only applies on SysML v2 model elements. That's done in the Create Details view. Another example of customization is the standard libraries. The SysML v2 specification comes with a lot of standard libraries, allowing you to not redefine common elements such as, let's say, for example, units or mathematical functions. It's very useful. So to be compliant with the specification, we created a SysML v2 model for each standard library. The mass attribute we've seen earlier in our textual example came from the ISQ-based standard library. After that, the goal was to load these read-only libraries each time a project is created or opened in SysON. So at server start, we load all the standard libraries in an EMF resource set. So that's not shown in the screenshot you see on the screen. It's done in the SysML standard libraries configuration class. Then we have implemented an eye-editing context processor and provided it as a Spring service. The eye-editing context processor, coming from Sirius Web, allows to modify a project when it's created or opened. So in the pre-process method, we copied the EMF resource set containing all our loaded standard libraries. On the screen, it's the source resource set. Into the EMF resource set of the project, on the screen, it's the target resource set. So it's the copy is done in the code in here. So with that, we can make references to any element of standard libraries in our SysML v2 models. Customization is also possible on the front-end side. For example, the icon on the top left corner of the application can be changed. It's quite simple. All you have to do is to use the navigation bar icon extension point provided by Sirius Web and provide your own icon instead through a React component. In our case, the SysON icon React component is just an SVG icon component from Material UI. Another example is the theme of the application. In SysON, we have a purple and gold theme. You can provide your own theme, which should be a Material UI theme, as you can see on the left side of the screen. The theme comes from Material UI. Then, when you declare your Sirius Web application component, you can pass your own theme, here SysON theme, that will override the default theme. Another example about front-end customization is in SysON is the footer, the home-page footer. Here at the bottom of the application homepage, we have provided our own footer. It also works with an extension point from Sirius Web, the footer extension point. Our footer is a very simple React component using a typographic component from Material UI. A last example of customization is node custom shapes. By default, Sirius Web only provides rectangular shape and image shape for graphical nodes. But Sirius Web allows you to provide your own graphical shape. That's what we did in SysON for packages and commands graphical nodes. On front-end side, you have to declare a node type registry containing all your node type contributions. Here, we provided two contributions, one for the package, the SysML package node, and one for the command, the SysML node node. The node components should be React components and return XY-Flow nodes. XY-Flow is a library for building node-based UI, and Sirius Web use it for rendering diagrams. The node type registry coming from Sirius Web is then passed as a parameter of the Sirius Web application component. On the backend side, you have to implement an inode style provider from Sirius Web and provide it as a Spring service. You also have to declare a very small EMF multi-model extension, which is not visible on the screen, with one in-class inheriting from the node style description from the Sirius Web diagram meta model. Then the create node style method is mostly a converter from the view meta model, the one manipulated by the API builder we've seen before, to the internal data structure of Sirius Web diagram. Before the end of this presentation, just a few words about the test in SysON. We have backend test, a mix of classic JUnit test and integration test, which relies on a Sirius Web API, allowing to launch a real backend and perform real user actions, but without the front end. On the front-end side, we have Cypress test, a framework allowing to create graphical tests. But it's quite hard to maintain a Cypress test for us. So from now on, we only add them if we don't have other choices. All the backend and front-end tests are automatically launched on each pull request and each commit in our continuous integration builds on GitHub. So that's all. Thank you for attending this presentation. We hope it helps you to better understand what is SysON and what is our philosophy about it. I also would like to thank everybody at OBO that has contributed to Sirius Web and SysON. This is a collaborative work involving a lot of people through the years. If you need more about SysON, do not hesitate to visit its website or get the code on GitHub. Also, do not hesitate to reach us through the website or directly by email. Thank you again. So if you have any questions, I'd be glad to answer it. Question here?
Thank you for your talk. Which techniques do you use to implement textual DSL?
Sorry, can you speak louder, please?
Thanks for your talk. Which technologies do you use to implement the textual parts of SysML, so the textual DSLs and the editors?
Okay, so we don't have textual SysML inside SysON, okay? But to parse the textual SysML and to import it as a model elements conform to our EMF meta model in SysON, we rely on a tool called SysIDE, SysIDE, a tool made by a company named SenseMetry. They have a very beautiful VS Code extension. Here I can see, here you can see SysIDE. So we rely on their parser to parse the textual notation, and then our SysON SysML import module we've seen at the beginning of the presentation is just a converter from their AST to our model.
I see. Okay, I got it. Yeah, thanks a lot.
Thank you.